Hello, this is Frank with Frank's Beautiful Rocks and Minerals. You are looking at euplopes, which are siliceous microorganisms that you can't see by eye. Their tests are made of silica. They're marine organisms, meaning they live in the ocean. They're turbidites, meaning that they are driven by ocean currents. I wish to talk to you about the chemistry of the oceans and the sediments that are on the abyssal plains or bottom parts of the oceans. The abyssal plain is not the lowest region of the oceans. That would be the Hadal region. And lower than the Hadal region are the subduction zones, where you find trenches. Let's take a look at diagrams describing the chemistry and sediments of the oceans. Here's a diagram of the ocean to the bottom. This is the atmosphere. In the ocean, chemical reactions occur. For example, aqueous carbon dioxide mixes with water. Some carbon dioxide goes off as gas, forming H2CO3, or carbonic acid, which is acidic, forming HCO3, negatively charged. Here is where it's acidic. The HCO3 negative gives up a proton, which is present in acids and has a positive charge, forming the proton plus CO3 negative 2 . At the bottom of the ocean is calcium carbonate, CaCO3. By means of dissolution, calcium ions plus CO3 negative 2, this would be carbon dioxide if it was CO2, with the hydrogen ions forms HCO3 negative. Back at the bottom of the ocean, calcium carbonate, through the process of precipitation, comes from CO3 negative, combines with calcium and CO3 negative 2. A proton is lost, which is acidic, and precipitation leads to calcium carbonate. Here's another diagram. Here we see the ocean floor. This is an oceanic trench, which is an area where there's volcanic activity. The seafloor is only 6 to 10 miles in depth and breaks, and magma comes up to the surface at the oceanic trench and at the oceanic rift, and releases different chemicals, including many elements such as iron, magnesium, calcium, phosphorus, sulfur, and others. We have precipitation chemistry and a black smoker. This is a black smoker in the rift, and that releases those elements. This is hot. (300°C). It's a flocculent flow. Seawater descends and is recycled up into the rift. Here we have Seafloor spreading, which results in continental drift. The seafloor from the rift moves left and right of it. Under here, we have HT flocculation zone. Can't read that. Should be 800°C. Seawater comes down. It's evoluted seawater. Repeats the process. Subseafloor microbial biosphere enters here, which we'll talk about in a moment. We have magnesium and sulfate in this region here. This is basalt. We have metalliferous sediments, and iron magnesium crusts. Hydrogen, chlorine, iron, manganese, hydrogen silicate, hydrogen sulfide, methane, carbon dioxide, calcium, potassium, lithium, copper, zinc, lead, and other elements. This is the magma at 12,000 degrees Celsius underneath the rift zone. From the rift zone, we get helium, manganese, H4S2O4, I'm not sure what that is, iron hydroxide, MnO3, there's a change in temperature, of course it's hot, methane, iron, and FeXSY to the 1. We got radon-222, hydrogen gas, and hydrogen sulfide coming up from the continental rift. This is a cross section from one continent to another across the ocean floor. And we see the continental slope, we see the continental shelf and the continental slope in the neritic zone, and in the pelagic zone we have such things as seamounts and guyots. Guyats don't reach the sea surface. These are underground volcanoes. Many of them are paleovolcanoes, or no longer active. Seamounts. An example of a seamount is the Hawaiian Islands. This is near a subduction zone, and it is called a trench. It's very deep. The deepest trench is off the Philippine Islands, called the Marianas Trench, the deepest part of which is the Challenger Deep. And then we come up across the continental slope and continental shelf of the next continent. But what's the chemistry on the seafloor? The chemistry consists of this. Right here is calcium carbonate ooze below clay in warm water, and in cold water we get silicate ooze and calcium carbonate ooze. Radiolarian shells, or tests, contain silica, siliceous ooze. Foraminifera and protozoans contain calcareous ooze. These are the microorganisms that fall to the bottom of the ocean floor and bring silica and calcium carbonate. Larger organisms bring other biogenic sediments, rich in carbon, to the ocean floor. There's not much life in the middle of the oceans, but the sediments do occur here. And the sediments occur also close to the continents. That's at 5,000 meters depth. Remember, as you descend in the ocean, you are decreasing in temperature and increasing in pressure. These are radiolarians, or radiolaria. Those are their tests, which contain silica. They're very beautiful under the microscope. These are foraminifera. These bring silica to the bottom of the ocean. And I can hope you appreciate the chemistry and sediments of the ocean floor. And this is Frank with Frank's Beautiful Rocks and Minerals. If you wish to contact me, my email is frankreiserrocksminerals@gmail.com. Reiser is R-E-I-S-E-R. And always remember to keep looking down.